Good morning guys and welcome back. In this video we're going to study ANOVA, the analysis of variance, but we're going to do it using Excel and not analytically. That's why I have attached under this video the analytical way of doing ANOVA. You're not responsible for it, but if you want to understand it more, you should do it by hand. So you can go to this link and watch the video. Basically guys, ANOVA, as its name, this is the analysis of variance. And remember, what is the variance? The variance is the distance from this x to the mean of these variables on a group of population. So the variance is basically how far is this x from its mean. So why ANOVA is the analysis of variance, we're gonna see why. But what you should know guys, that ANOVA is a statistical method used to compare the means of two or more groups. So why I should compare these means, and why is it important to know if these groups have the same means or not? Because in fact guys, if I need to test the effect of a certain medication or a certain parameter on a certain population, I have to make a comparison of the means. For example, if I need to see the effect of music on the students in the class, I need to make some comparison between non-music class and the music class in order to see this effect. And also guys, you have to know that ANOVA is very important in medicine, because if I need to test a medication, if it is working or not on a certain population, I should use it. In fact, guys, if I take this example here, and this is the same example taken from the link below, this example illustrates the effect of a certain medication on the level of anxiety. And you know guys, from psychological point of view, whenever you give any patient a medication, even if it doesn't have any effect, he can feel better. So in order to remove this effect, in order to remove this psychological effect, I have to test this medication using 3 dosages: 0 milligram, 15 milligrams, and 100 milligrams. And then I'm gonna study the mean and analyze the variance using ANOVA. How? Basically guys, in ANOVA, I have to suggest the null hypothesis. The null hypothesis states that their means are equal. If their means are equal, this means that the medication doesn't have any effect on my patients. So guys, this null hypothesis or the alternative hypothesis states that they have the same mean, and it is called H0. In ANOVA, I'm gonna test this H0. Is it valid or not? Is it valid means, do they have the same mean or not? And the second one is H1, whenever I have one different mean. But I cannot know from ANOVA what is this different mean. I can just know that they do not have the same mean, and in this example, if they do not have the same mean, this means that the medication has a certain effect. Alright, so I'm gonna test H0 or H1. Remember, H0, which is the null hypothesis, is when they have the same mean. H1, when they do not have the same mean. How to verify if H0 is correct or if it is valid or not? Basically, it is by finding F. What is F, guys? F is basically the ratio of the mean square of variance between the groups, which is group 1, 0 milligrams, group 2, 50 milligrams, and group 3 is 100 milligrams. So F is the ratio of the mean square of variance between groups over what? Over the mean square within the groups, within each group. What does this mean? So guys, if I need to find if they have the same mean, I have to know what is the variance of each group and what is the variance between groups. If F is neglected, So if f is very small, this means, guys, that the mean square between groups is less than the mean square within, or in other words, the mean square between groups is negligible. If the mean square between groups is negligible, which means the variance is negligible, then they have the same mean. Because I know, guys, that the variance is what? The variance is how far is this x from x bar, which is the mean. So if the variance between groups is very small, then all my data are very close to the mean, which means they have the same mean. However, if f is not neglected, or if the mean square between groups is not neglected compared to the mean square within the groups, they do not have the same mean. So guys, based on this f, I can predict if h0 is valid or not. If h0 is valid, then they have the same mean. Then in my example, there is no effect of this medication on this population. So guys, how to know if f is neglected or if f is significant? It is using f critical. F critical is basically analytically given by this table, but if I'm gonna do ANOVA on Excel, F critical will be given on Excel. So I'm gonna see this F critical, and then I can compare my F to this F critical. If F is less than F critical, then I can say that F is neglected, the mean square between groups is neglected, then H0 is valid and they have the same mean. If F was greater than my F critical, this means that the mean square between groups is not neglected compared to the mean square within my groups, and this means, guys, that H0 is not valid. They do not have the same mean. Let's do it using Excel. So guys, in this problem, Susan predicts that students will learn most effectively with a constant background sound, as opposite to an unpredictable sound or no sound at all. She randomly divides 24 students into 3 groups of 8, and all the students study a passage of a text for 30 minutes. Those in group 1 study with background sound at a constant volume in the background. Those in group 2 study with noise that changes volume periodically, and those in group 3 study with no sound at all. After studying, all students take a 10-point multiple choice test over the material, and their scores follow this table. So Susan, guys, wants to know if there is an effect of the background sound on the test scores. And I'm gonna do this using single ANOVA factor. Can I say that this sound has an effect on my test score? Basically, guys, this constant sound has an effect if the 3 groups have different means. In other words, if H0 is not valid. What does this mean? H0 is not valid means F should be greater than F critical. Now, if F is less than F critical, then H0 will be valid. Then they have the same mean. Then I cannot say that this sound has an effect on the test score. So let's do it now using Excel. So guys, here I have the table, the same table, which represent the test scores versus the sounds. I have some constant sound, random sound, and no sound at all. How to do ANOVA? So I'm going to select data analysis, ANOVA single factor, because in fact, I'm studying the single factor, which is the constant music, all right, on the test scores. So I'm going to say yes. And then, guys, my input range will be this table from A2, from the name of this row constant sound, until I4, all right? And don't forget that these are groups in rows. whenever you click in rows, then the labels will be in the first column, all right? If it is in columns, the label will be in the first row, obviously. So I'm gonna select rows, and then I'm gonna say that the labels are in the first column because I have selected the title, all right? Now you can keep alpha. Alpha is the error, so I'm gonna keep it always 0.05, and then the output range will be any cell right here. So I'm gonna select this one. And then I'm going to click on OK, and let's see what is ANOVA about. Right? So guys, here is the summary. So let's see, guys. You can see F critical. F critical here is the benchmark F, the reference F that I need to compare F to. So guys, this is F critical and this is F. So I can find, guys, that F here, so my F here is greater than F critical. What does this mean? This means since F is greater than F critical, and I know that what is F? F is equal to M mean square between groups over the mean square within groups. So guys, this means that F is not neglected at all, which means the mean square between groups is significant. What does this mean? If the mean square between groups is significant, then this means that they are far from the mean. So there is a very large variance. Large variance means they do not have the same mean, which means H0 is rejected. And since H0 is rejected, they do not have the same mean, then yes, the constant sound has effect on the test scores. So this is a very simplified explanation on ANOVA and how to do it on Excel. Thank you very much.